Hello, welcome to my channel Ponvayra Citadel. I am Nalini Rajagovindan, and today in this video we are going to talk about experimental research, which is a type of quantitative research, and we are going to see many experimental research designs. Research design is like the blueprint for a building. It is the basic plan, and it is required for the smooth conduct of any research. In our previous video, we saw different types of research and how they are classified. And today in this video, we are going to discuss about one of the most important research type, namely experimental research, which comes under quantitative research. Quantitative research is one of the research paradigm. I have told that in our previous videos. But experimental research can be defined as a systematic scientific approach to research. It's the process of carrying out research in an objective, controlled, and scientific fashion so that precision is enhanced and accurate conclusions can be drawn regarding a hypothesis statement. What is hypothesis? It is a tentative solution, or to be more precise, it's an academic guess to a problem. Research hypothesis is a predictive statement that relates an IV with a DV. IV is the independent variable and DV is dependent variable. Mind that predictive statements which are not to be objectively verified, or the relationship that are assumed and not to be tested, are not termed as research hypothesis. More about hypothesis I'll be publishing a separate video. And see, in this slide, we are going to see the main principles used in experimental research. Experimental design is a group of research designs, and they use the following principles. Number one, manipulation of one or more independent variables, control of one or more independent variables, and three, observation of the effect of the IV on the DV to establish a cause and effect relationship between them. And fourthly, randomization. We will see each of these principles used in experimental design in detail now. You will get to know these terms. What do they mean? Like randomization, manipulation, control, etc. Always remember, if you want to establish the cause and effect relationship between IV and DV, then you should go only for experimental research. Basically, there are three different categories of experimental design. They are: number one, pre-experimental; number two, quasi-experimental; and number three, true experimental. What you are seeing in the figure is a type of true experimental design, and this is called randomized pre-test, post-test, control group design. Now, don't get frightened. I will explain each of this in detail. Now let me explain the terms used here, like randomization, treatment, control, and observation with an example. Suppose we want to test the hypothesis that usage of dictionary by the students in the English language class improves their vocabulary. Now this is the hypothesis. I repeat, usage of dictionary by the students in the English language class improves their vocabulary. Now we want to establish the cause and effect relationship between using dictionary, which is the cause here, and improvement in vocabulary, which is the effect. We are going to establish this cause and effect relationship by means of an experiment. Now we will take two groups of students of the same class, one as experimental group and another one as the treatment group. I'm sorry, experimental or treatment group. The experimental group is otherwise known as treatment group. And the second group is called control group. The experimental group is so named because it is going to receive the treatment. That is why it is called experimental group or treatment group. It is the group which is going to receive the treatment, which is here the using of dictionary by the students in the English class. Now, the other group, the control group, is not going to receive this treatment. That is, it's not going to, the students in this control group are not going to use dictionary in the English language class. And that is why it is called control group. And this group is used only for comparison purpose. The important point to be noted here is that these two groups should consist of students of same age, same intelligent level, and same motivational level. Then only we can call these two groups as equivalent group. The only difference between them is one group is going to receive the treatment and the other one not. It's not going to receive any treatment. Randomization is followed in both. That is, the selection of student sample and that is the students whom we are going to select for participating in this experiment should be randomly selected by the researcher. What is randomly selecting? That is, we should not have any bias. You should not give any preference for any students. You just select them without any pre-plan. That is randomization. And we will discuss about randomization in detail in the video about sampling. So randomization is followed in both, that is in the selection of the student sample and also in assigning them to the two groups, because we are going to assign some students to the first group, namely the experimental group, and we are going to assign some students to control group. And in assigning them, in this assignment also we are going to follow randomization. We are not going to be biased. We will just pick the students randomly and assign them to either group, experimental group, or the C group, that is the control group. That is, while selection of the students from this class population, there should not be any bias and each student should be given equal chance for being selected into the study. And why this randomization? This is to avoid any alternate explanation for the effect. If at all there is going to be any effect, it should be only due to the treatment that we are giving. What is the treatment? That is the students using the dictionary in the English language class. So there should not be any other alternative explanation for the effect. The only explanation should be the treatment. So that is why we are taking this precaution of randomly selecting the students and randomly assigning them to both the groups. Nothing else, no other factors, no extraneous variable should explain this effect. Only this treatment should explain this effect, any effect that we see at the end of the treatment. So this is the whole purpose of randomization. Controlling all other factors like the intelligent level or the motivational level also eliminate alternate explanation for the effect. So all the variables like intelligence level, motivation level should also be controlled. That is, we should have the two groups which are equivalent in all the other respect except for the treatment. A pre-test in vocabulary is conducted before giving the treatment at the beginning of the experiment to both the groups. This is called before test, or sometimes it is called pre-test. Then the treatment, that is the usage of dictionary, is given to the experimental group of students, and nothing is given to the control group. They are not allowed to use the dictionary during the language class. Say after a month, another test which is called post-test or the after test in vocabulary is conducted for both the group of students. The test marks are observed. Now, if you see any improvement, see, watch my words, if you see any improvement at all or more improvement in the post-test of the experimental group than in the control group, then we can conclude that our hypothesis is correct and we can accept it and establish that using dictionary causes improvement in vocabulary. So that is our hypothesis. Using dictionary causes improvement in vocabulary is our hypothesis. So now the hypothesis is correct because we have seen improvement in the post-test score. Thus, the cause and effect relationship between the independent variable. What is the independent variable here? Using dictionary. And DV, dependent variable. What is the dependent variable? That is vocabulary. So the cause and effect relationship between IV and DV is established. And this is called randomized, pre-test, post-test, control group design, because we have in this experiment randomization of the sample, randomization of the assignment of the students to both the groups, pre-test conducted, post-test conducted, and there is a control group which did not receive any treatment. So it is a type of true experiment where we see all the three necessary components of an experiment, namely manipulation of IV. What is manipulation here? What is the IV which we are manipulating? That is the treatment, usage of a dictionary. So we are manipulating. We give them to certain group, we don't give them to another group. So that is manipulation. And control of other IVs. What are we controlling here in this experiment? We are controlling the intelligence level and the motivational level. So control in the sense we are choosing the two groups in which the students of both the groups are of same intelligent level and same motivational level. That is controlling. And the third component is the randomization. So we have followed randomization in sampling and randomization in assignment. So this is an example for a true experimental design, and it is called, this type is called randomized pre-test post-test control group design. Here what you see in the figure is the comparison between the three basic types of experimental designs. You have already seen a true experimental design, namely randomized pre-test post-test control group design. Another example for true experimental type is Solomon 4-group design. And it's actually a combination of two designs. One randomized pre-test post-test control group design, what we discussed just now, and one more design, namely randomized post-test only design. Once again, it is a true experiment because all three components are there. manipulation, which is also called treatment or intervention. Sometimes it is also known as intervention. Control of other independent variables, like I have told you, the intelligence level and motivational level, and the third component of any true experiment, namely randomization. Now, you should be asking your question, why 4 groups? If randomized 2 groups, pre-test, post-test group design is also called as 2-group design. See, pre-test, post-group design is also known as 2 groups because there are 2 groups design. And when already we have one true experimental design, why then one more post-test only design? Why we are combining 2 tests in randomized Solomon 4-group design? This question should come to your mind. Now the answer is simple. This combination is just to eliminate the reactive effect of pre-test. What is the reactive effect? It's the practice that students get after the first pre-test, because once they have the pre-test, they are, they get the practice, what it is like, they are sensitized about the test, what type of questions will be asked. So how they also learn the time management. So that will have the effect on the post-test. So this pre-test will have an effect on the post-test. In order to eliminate this reactive effect of the pre-test, we are combining these 2 designs in Solomon 4-group designs. By having 4 groups, we can eliminate this reactive effect of the pre-test by subtracting it from the total effect. Even though Solomon 4-group design adds to the internal and external validity of the research, it is practically very difficult to organize 4 groups in a research design, since it involves more time, more energy, and more money. See, imagine selection of students for 4 different groups, randomly selecting them and assigning them. So that will take a lot of time, which may not be available for a teacher, for a researcher in a classroom. But if you take that pain, it will add to the internal validity and external validity of the research. What is internal validity and what is external validity? Internal validity refers to the degree of the confidence that the causal relationship which you are going to or trying to establish is not influenced by any other extraneous variables. So here the cause is due to only the treatment and nothing else. We want to make sure. So that is the internal validity. If only you make sure that no extraneous variable is affecting the experiment, then you can be sure of the cause, that this treatment alone causes the improvement in the score of the post-test, namely the vocabulary. So there you can be more confident if you are eliminating all the other extraneous variables. So this Solomon 4-group design establishes the internal validity and also the external validity. What is external validity? It refers to the generalizability of your findings to other contexts. What is generalizability? It means that any research, any findings you are arriving at in your research should be applicable to all the other experiments conducted in the same context, in the same manner. So that is called generalizability. So any research should be having this element of generalizability. Any findings you do, it should be the other researcher, if they follow the same method, that is replication. It's also called replication. If they follow the same methods, they should arrive at the same conclusion. So that is external validity, generalizability of your findings to other contexts. This Solomon 4-group design ensures both the internal validity and external validity. That is the advantage of this Solomon 4 group design over the just randomized pre-test, post-test control group design. And the next group is the quasi-experimental design. And in this quasi-experimental design, any one of the three components or any one of the three conditions may be missing. Randomization will not be there. So there won't be random selection of sampling. There won't be random assignment of the sample. So we will not have two equivalent groups, but we will have two non-equivalent groups here. That is why you see here in quasi-experiment NE. NE stands for non-equivalent group. Why they are non-equivalent? Because there is no random selection of sampling. There is no random assignment of the students to both the groups. But treatment groups and control groups are there. Two groups are there. It is a two-group design. Treatment group is there and control group is there. And pre-test and post-test are there. So BT stands for before test or the test before, and AT stands for test after the treatment. BT before test and BT before treatment and AT after treatment. T stands for treatment, not test. Okay. So O stands for observation. What is observation here? That is the test. You are observing the data by conducting a test. So OBT is observation before test. And X is the treatment given. X stands for the treatment given. And OAT is observation after treatment. That is a test, post-test. And NE stands for non-equivalent group and R stands for randomization. When there is randomization, you will not see NE because they are randomly selected and randomly assigned and both the groups are equivalent groups. So they are called RR. So here in this example, what you are seeing in the quasi-experimental, two conditions are missing. Randomization is missing, but treatment is there, and control group, two groups are there, before test and after test is there. So only one condition is missing, that is randomization. In quasi-experiment, out of the three conditions, only one will be missing, and it's usually the randomization will not be there. Then it becomes quasi-experiment, partly true experiment. And in the third type, namely the pre-experimental design, out of the three conditions, two will be missing. You will see only one condition. So the missing one can be any of the three. See, the randomization may not be there. And no control group. So that means only one group is there. And no pre-test, post-test. Only one test is there. Look at the first example given in the pre-experimental one, where there is no R, no randomization there, and there are no two groups. Experimental group and control group is not there. There is just one group. And no pre-test is there. Only one test is given. That is after treatment. Just you give treatment. That is a teacher. The same example what we studied for the true experiment, where you divided the students into two group, experimental group and control group, and you conduct a pre-test before giving treatment, then you give treatment and conduct post-test. Here, for lack of time, for lack of money, and for practical purposes, the teacher may just give the treatment. That is, the teacher comes to the classroom and gives dictionary, allows the student to use the dictionary in the English language class and give a test. And she is convinced that their performance is good because she's so sure of it that using dictionary will cause improvement in the vocabulary. So she is not randomization. She has not randomized she has not divided into two groups, and she has not conducted pre-test. Just one group, post-test only design. So it is also called, sometimes it is also called as informal experimental design. See, you can classify the experiment into pre-experiment, quasi-experimental, or true experiment, and also some people group them as formal, informal, and semi-formal designs. Okay, it varies in different books. But you just understand the concept, then you will be able to appreciate the differences. And you will be able to follow whatever is given in the book, whether they follow this classification or this type of classification. And in some designs, the randomization will not be there and no pretest, but two groups are there. In the second design, the second example given in the pre-experimental design, you see the second one where it says non-equivalent post-test only, and here two groups are there, NE, NE, non-equivalent groups, no randomization, that is why they are non-equivalent. And the first group, you are giving treatment, so it is the experimental group or the control group. I'm sorry, experimental group or the treatment group. You are giving the treatment and no pre-test. You're just observing it at the end after treatment. And the second group, which is the control group, no treatment and no pre-test, and you give them only post-test and you observe the data after the treatment. So here two grouping is there as experimental group and control group, but no randomization. The students allotted or not allotted according not according to randomization principle. They are just there's no randomization. Students are allotted into without randomization. I know there is also no pre-test. The two groups, we cannot say that these two groups, treatment group and the control group, are equivalent in all the respect. They may have different intelligent level, and these two groups may have different motivational levels. So there may be some extraneous variables operating in this experiment. So that is why we say this is not a true experiment, but it is pre-experimental or informal experiment. So in this second design, you see no randomization, but the two groups are there and treatment is there and no pre-test. And in the last example given in pre-experimental, the third one group, pre-test, post-test design. And here there is no control group at all. There is only one group. That is the experimental group or the treatment group, which is receiving the treatment X. And you give it pre-test and post-test. There is no control group. So no randomization also. So two conditions are missing. Randomization is missing and the control group is missing. Only pre-test, post-test are there. The third design, look at the figure. So this is also one of the examples for pre-experimental designs. Based on the research question, what is your research topic? What is that you want to establish? The researcher has to choose the design, particular design that will most suit his or her needs. And going from the pre-experimental design to true experimental design through the quasi-experimental design, there is an increasing order of robustness. So what is robustness? The efficiency of the experiment increases starting from pre-experimental to true experimental. So in between is the quasi-experimental. Only one condition is missing in quasi-experimental. And in pre-experimental, two conditions will be missing. But in true experimental design, all the three conditions will be met there. So there you see an increasing order of robustness in these three different types of the research designs. Well, we have come to the end of the session. I hope you have understood the different types of experimental research designs and you are ready now to plunge into a research topic. I'm sure you like this video. And please don't forget to subscribe to my channel Pon Virus Citadel and press the bell icon to receive the notifications. Thank you.